Hi everyone, so this is a kind of a review video on a couple of topics related to the SAT and equivalence. They love seeing what you know about equivalence. They want to know if you understand the difference between equivalent forms of the same, say, equation. For example, linear functions or linear equations can be written in the form y equals mx plus b, or they can be written in point slope form, so y minus y1 equals m times x minus x1, or they even can be written in standard form, ax plus by equals c. These are all equivalent forms of the same equation. They also ask you, which equations might be equivalent to 2x plus 4y equals 6. They don't ask you to solve it. And in those cases, what you're usually asked to do is just simplify it. And in this case, you might notice that they all have even numbers. So I could actually simplify it by dividing them all by 2. So x plus 2y equals 3 is an equivalent equation. All right, well, with this idea of equivalence, it's really helpful for you to know to work backwards and forwards with different patterns. So you can look at something and you know it either going forwards or backwards. So here's an example. 2x plus 5, quantity squared. I like to refer to this as the square of a binomial. Square of a binomial. Now, the result of this will always be a perfect square trinomial. If you multiply it, it will be a perfect square trinomial. Now, if you've taken my class before, we spent a lot of time on the pattern to this. How do you get the perfect square trinomial by looking at it? Well, the rule is you square the first term, so you get 4x squared. You double the product of these numbers. So product means multiply, so I do 5 times 2x, which is 10x, and then I double it. I get 20x, and then I square the last term. So again, if I see the square of a binomial, I know my result, if I multiply them, is going to give me a perfect square trinomial. These are equivalent expressions. If you factor a perfect square trinomial, you're going to end up back at the square of a binomial. Now, if you forget the rule, that's okay. Just make sure you don't distribute the 2 through the expression. Remember, when you square something like, x squared, it means x times x. So in this case, 2x plus 5 squared means 2x plus 5 times 2x plus 5. And then you can multiply the polynomials to get 4x squared plus 20x plus 25. So knowing this special factor pattern also allows you to go between equivalent forms quickly. All right, another equivalence that they like you to recognize is the different forms of a quadratic function, okay? A quadratic function. So standard form of a quadratic is ax squared plus bx plus c. That's standard form. We also have vertex form, which is x minus h squared plus k, where hk is the vertex. So y equals and y equals. In this one, the y-intercept is 0, c. You can see those numbers as constants in the equation. And the third one, kind of my favorite one, it's called intercept form. I like to call it factored form because it looks like they're factored. So it might be a x minus p, x minus q. So these are actually all the same form of a quadratic. They're just written differently. So they're equivalent. All right, so that's a basic idea of what equivalence is. So I want you to pay really close attention when you're doing problems and it asks, what's equivalent? And I also want to make sure that you understand that this sign equals, yes, it means equivalent, but I want you to think of it as meaning is the same as. Is the same as. Okay? For example, 4x squared minus 9 equals 2x plus 3, 2x minus 3. 4x squared minus 9 is the same as 2x plus 3, 2x minus 3. I call this dots, that factor pattern, the difference of squares, dots. This is it in factored form. This is it in standard form. But they are equivalent forms of the same equation. All right, or of the same expression. All right, guys, hopefully that was helpful. Hopefully it gave you a little insight into what they mean when they say equivalence and how they really want you to understand equivalence. Have a great day.